Good afternoon. In this lecture, we have uh, studied the linear programming problem for formulation, mathematical formulation. And first, we have seen the wide range of the linear programming problem: the product mix problem, make or buy decision problem, choice of alternative problem, sale budget problem, production budget problem, purchase budget problem, advertising problem, and a range of linear programming problem, that is capital mix problem, diet problem, nutrition problem, learning problem, team problem, transportation problem, assignment problem, job scheduling problem. And next we have seen the formulation of the linear programming problem. Thus, we have seen the problem: a garment manufacturer has a production line making two style of shirt. Style 1 need 2 gram of cotton thread, 30 gram of thread, and 300 gram of linear thread. Corresponding requirement of style second are 200 gram and 200 gram and 100 gram. The net contribution are rupees 19.50 for style 1 and rupees 15.90 for style second. The availability inventory of cotton thread thread and line thread are respectively 24 kg and 26 kg and 22 kg. The manufacturer wants to determine the number of each style to be produced with the given inventory. Formulate the linear programming model. Step first, we have find the objective function, and first we have find the objective function for the problem is minimize or maximize. That is, we have depending on decision variable, there are of each style to be produced, number of style 1 set say x1 and number of style second set say x2. Objective of the decision maker: maximize the total contribution, given that the contribution per unit in rupees 19.50 for x1 and 15.90 for x2. Hence the objective function is maximize. Here decision maker wants the maximize profit. That is, hence the problem is maximize. Z equal to 90.50 x1 plus 15.90 x2. This is the objective function. Then step second, the constraint: the availability of cotton thread. Style 1 need 200 gram and style second need 200 gram and 24,000 gram is available. Corresponding constraint is 200 x1 plus 200 x2 less than equal to 24,000. And availability of thread: style 1 needs 300 gram and style second needs 200 gram and 26,000 gram is available. And then corresponding constraint is 3000 x1 plus 2 300 x1 plus 200 x2 greater than equal to 26,000. Availability of linear thread: style 1 need 300 gram and style second need 100 gram and 22,000 gram is available. And then the corresponding constraint is 300 x1 plus 100 x2 less than equal to 22,000. And non-negativity constraint: since the number of shared cannot be negative, that is the number of shared atoms is not negative, that is we have not considered the shared is -1 -2. Therefore, since the number of shares cannot be negative, add the non negativity restriction x1 x2 greater than equal to 0 and complete the linear programming formulation. For the time being, we ignore another restriction on x1 and x2 and that they be integrate. If that restriction is also add, we write x1 x2 greater than equal to 0 and integrates, then this becomes an integrate linear programming which we will see later. That is, solution of the problem 1 is x1 is the number of style 1 shirt and x2 is the number of style second shirt, and that is maximize z equal to, that is company has want to the maximize profit, therefore problem is maximize z equal to 19.50 x1 plus 15.90 x2, that is the contribution, and subject to the constraint is 200 x1 plus 200 x2 less than equal to 24,000 cotton, and 300 x1 plus 200 x2 less than equal to 26,000, and 300 x1 plus 100 x2 less than equal to 22,000, and x1 x2 is greater than equal to 0, that is the non negativity constraint. This is the formulation, mathematical formulation of linear programming problem. In this lecture we have solved the how solve the mathematical formulation of linear programming problem.